Present. It was
Great pleasure.
Good. So the eye has two functions, just like the ear, where the ear gives us the ability to hear and keep balance. So does the eye have two functions. It makes us see and see pictures and our surroundings, but it also tells us some very important cues about time. And this is something that we need to take into consideration when talking about light going forward. And we need to integrate it into how we make good lighting. So one of the things that basically has happened is that CIE has introduced the term of integrative lighting to try and deal with this. But why now? That's a good question. I would argue, and this is what I'd like to talk about in this presentation, that there are at least 6 key drivers to this. One is the need for solving a problem. The lighting science, which tells us, and the science which tells us we need to take this into account. Then there's innovation in measurements, which I'd like to get into. There's lighting technology. There's early frameworks and recommendations, and these are happening as we speak. And then there are early examples and use cases that we can learn about. And this is what I'd like to talk to about today. So first of all, the need for solving a problem. Light and circadian rhythms are hardwired into plants, animals, most species on Earth, including humans. And for millions of years, the natural light-dark cycle and the changes in light-dark cycle, which is very scheduled, our body has basically adapted to this. But things are happening and things are changing. New modern lighting systems, the illumination of light at night, and the fact that we spend a lot of time in buildings away from, for example, daylight, might actually interfere with these very, very ancient systems. And this might mess up our biological clocks, our circadian system, and a lot of other physiological responses, to a point where American Medical Association in 2016 actually adopted political guidelines to the reduction of reducement of harm from high intensity streetlights. Another quite interesting fact is how modern lighting can be summarized. This is from Thiel Ronnenberg's group in Germany, showing that over a 10-year period, we basically get less light, less daylight. We sleep less, and then we get social jet lag, being the difference between mid-sleep on weekdays and weekends. So our circadian clocks are not synchronized. So there's a problem here that we need to solve, and light is a major benefactor of this. So what about the lighting science? What does that tell us? Around 20 years ago, we learned of a new receptor system within the eye, an EPRTC or PRTC system with the photopigment melanopsin. The conclusion of that is that there's a new revolution within light and lighting. It's not only a visual aspect, we also have these non-visual aspects driven by intrinsically photosensitive retinal ganglion cells. What's important to mention here is that we actually do see quite a good correlation between these EPRTC cells, although there are many other involved in circadian entrainment, circadian phase shifting, and melatonin suppression. And we see, this is also where we see the lighting community targeting. But what I want to stress very carefully is that we know from research now that these EPRTC cells, they stimulate a host of neuroendocrine and neurobiological responses to light. And we need to take this into consideration when we do lighting. And this is our subjective alertness, it's cortisol stimulation, it's our pupil light reflex, it is photo entrainment and seasonality, and even food anticipation, mood, and hippocampal learning. So it's light is quite important for us. So to mitigate some of this, basically from within lighting industry, we've seen a host of concepts to target this with a new guideline in their vocabulary which is integrative lighting. And again, this is adopted in the CIE vocabulary now. Now, we also hear about concepts such as human-centric lighting. And just to give you an example, this was published, I think it was actually last week, by Hauser and Boyce and Saiter. And they basically looked into myth, magic, or metaphors of integrative lighting and human-centric lighting, concluding the following. The phrase integrative lighting avoids the hype of human-centric lighting and encapsulates what lighting aspires to be. Something old, which is core ingredient of good lighting, driven by good design teams, lighting designers, etc. And then the fact that light is still for vision, to be able to see. Light is still for visual comfort, and it is as important as ever. But there's a new thing that we need to integrate, being the new, which is an awareness of non-visual responses to light, neuroendocrine and neurobiological responses that are important for human health. And then the realization that to meet this, we need to make design solutions within lighting to contrast day and night. And I would argue personally that this is one of the best examples of how a schematic framework could look like. This is actually from Karin Smulders from 2014, so it's nothing new. And what she basically stipulates is that we can use the image forming light and the non-image forming light. And the image forming light being good visual performance, visual acuity. Visual experience, this is where you hire a lighting designer. Then the circadian effects, as we saw in melatonin, phase shifting, and then acute circadian effects. This could be light's influence on alertness. But we need to be able to articulate what it is we want out of these lighting systems to be able to target this. Further, CIE has issued a roadmap for helpful interior lighting. And what's interesting about this is that they also describe classified influences of these processes. What about the individual, the age of the individual, visual impairment, stressors and other factors? What about amplitude of daily patterns? When we talk about circadian lighting, do we sufficiently talk about seasonality? I would argue not. And we need to be much better at that. And then also including these acute non-circadian effects in neurophysiology. And then also the changes within the retina. So what about these non-visual effects? Are they proven? Do we know enough? There's a lot we still don't know about this system. It's really complex. However, we are beginning to arrive at evidence that light is relevant for human behaviors, health and well-being. And we do see meta-analysis being published. This is from 2016, showing a great correlation with acute alertness, a great correlation with melatonin suppression, and a great correlation between concentration and performance using the 2D test, including depression scores. So the use of non-visual light is something that we should focus on. So what about innovation in measurements? How do we measure all of that? How do we check? How do we talk about it? Well, before 2002, we looked at measurements in the visual age. So we know all of these: Kelvin, lux, illuminances, glare, etc. These are as important as ever, and we need to focus on them. But I would argue that we've seen sort of two directions within how we measure these non-image forming approaches to light. This is a rough schematic, but around 2002, when we first encountered these EBRTC cells and melanopsin, around 2011, we saw NC describing this melanopic response. Bale and Lucas improved on this for the melanopic response. And then in 2014, we saw a breakthrough study from Lucas et al. Advocating that because of the complexity of photoreception within the retina, we need to calculate and measure light on each of the 5 photoreceptor systems within the eye. This is something that EU and CIE has adopted in a number of standards, and the newest CIE 2018-026 is actually adopting this. telling us that we now need to measure light on each of the 5 photoreceptors within the eye. This also means that we have the visual age and now the non-visual age. So couldn't we just use photopic locks to anticipate these non-photopic and non-visual responses? The answer is no. This is basically melatonin suppression. And as you can see, the melanopic locks is much better at prescribing melatonin suppression than the photopic locks value. So we need to measure light in a new way. And I would again argue we can also see that cyanopic and rhodopic is basically stimulating melatonin suppression as well. So please start to use the new toolbox. This is also what CIE is describing, recommending proper light at the proper time, concluding that 2 important well-studied human non-visual responses are out there, melatonin suppression and pupil control. And the evidence is accumulating that overall light sensitivity of these responses are largely controlled by melanopsin-based photoreception. If you want a high stimulation, you go for a high melanopic EDI during the day for alertness and circadian rhythm and good sleep. And in the evening, a low melanopic EDI to consolidate sleep. And to be able to use this, CIE has published this CIE S026 2018 methodology of optical radiation of EPRTC influenced responses to light, which basically measures all 5 photoreceptive fields within the eye, L, M, and S cones, rods, and a melanopic response. And together with this standard, CIE has published a toolbox, which is basically accessible online, so everybody can get access to it, which basically can take light spectrum and CIE approved light sources and give you basic quantities in irradiance, illuminance, and log photons equivalent of all 5 photoreceptive fields. So please start using